So resistance are connected across an alternating current supply or a source of alternating EMF. Current will flow through this. Let I be the value of instantaneous current. That is the current at any time. Let the EMF be represented by E is equal to E naught sine omega t, where E is the instantaneous value of EMF, E naught is the peak value, and at time t, omega is the angular frequency. Now, if I is the current at any instant of time, then the potential difference across R is given by IR. And this must be equal to E at that time. Only then the current can flow through the circuit. The EMF applied at any time must be equal to the potential difference across the resistance at that time for the maintenance of current, for the movement of current through the circuit. And E is equal to, we know, E naught sine omega t. Now using this relation, we can find out the I. So I at that instant will be equal to E naught divided by R sine omega t. Okay. Now, for the maximum value of I, sine omega t must be equal to maximum. So I naught, which is equal to 1, so I naught will be equal to E naught divided by R. So peak value of current, maximum value of current is given by E naught by R, because maximum value of sine omega t is 1. So what we get is I is equal to I naught sine omega t. So this is the form of alternating current that is passing through this resistance. And this is the form of EMF that has been applied across the ends of the resistance which is connected in the circuit. Now, looking at here, Ohm's law states that current flowing through a circuit is equal to the potential difference applied divided by the resistance. So this is similar to this. That means the peak value of current, alternating current, is equal to peak value of alternating EMF applied divided by R. So that means the current is being limited by the resistance R when source of EMF, alternating EMF is applied. It's similar to how the resistance limits the current in case of a circuit having a source, DC source. तो AC सोर्स हो या DC सोर्स हो, दोनों को इसमें रेजिस्टेंस जो है वो एक ही तरह से काम करता है, इसलिए रेजिस्टेंस जो है दोनों में एक तरह से इफेक्टिव है. So it can reduce the DC as it reduces the AC, or it can reduce the AC as it reduces the DC, that is direct current. Now let us compare these two, 1 and 2. You will see the phase of the alternating EMF and the phase of current at any instant of time is same. So both are in same phase. 1 and 2. From 1 and 2, E and I are in same phase. So there is no phase difference because E is equal to E naught sine omega t and I is equal to I naught sine omega t. So that means the value, if I draw the figure here and suppose this is for E and T, then if this is the curve for E versus omega t, then the curve in case of I versus omega t will also be such that the zero value of both occurs at the same time, maximum value occurs at the same time, and so on. Zero value at the same time, zero again at the same time, maximum in the opposite direction at the same time, and zero at the same time. So that means these two are in same phase. Now we can analyze this using a phasor diagram. So what is a phasor? Phasor is a phasor is a rotating vector that represents the quantity which is varying sinusoidally. So a rotating vector that represents a quantity which is varying sinusoidally is called a phasor. So a rotating vector which represents or that represents a quantity varying sinusoidally is called a phasor. So we shall now discuss the phasor or vector diagram. So in this case, the quantity I is changing as well as quantity E is changing sinusoidally. This is change, both are changing sinusoidally, so both are phasors. They both can be presented as phasors. So how we draw the phasor diagram? So this is the, suppose O is the origin, and suppose this represents the peak value of EMF at any time, so omega t, and this is the peak value. This vector is rotating, so as it rotates, its value, its projection on the x, y o y dash as well as x o x dash keeps on changing. So its value keeps on changing. If this is at this position, the value of E will be on its projection on the y-axis will be 0, and this is in this position, its value on the y-axis is equal to E naught, and this is in this position, the value, its projection is not equal to E naught but less than E naught. So we call this the value, we call this projection on the y dash as E, which is equal to E naught sine omega t. So it depends on the angle or omega t which it makes with the x-axis, which it makes with the horizontal direction. So if we move in the anti-clockwise direction, its value at different times will be different. Okay, so this represents E. So as t changes, the value of E changes, while this phasor E naught is rotating about the origin. That means E is changing sinusoidally. This E is changing sinusoidally as this phasor or this vector E naught is rotating in the, say, anti-clockwise direction in this case. And if we take the projection on x o x dash, so we can take the projection on x o x dash as well. But now, if angle is 0, E will be equal to E naught. But now, because this is the maximum value, now we'll have to write down, if we take the projection on x-axis, E will be equal to E naught cos omega t. So we need to remember this. अगर x to x net dash पे हम projection ले रहे हैं, तो instantaneous value of E will be a cos component of E naught. But when we take the projection along y or y dash, it will be the sine component of E naught. E naught. Okay, so these The length of this arrow represents the maximum value of this quantity. जितनी इसकी length है वो उस quantity की E की maximum value है. Now in this case, because I and E are in same phase, so I is also making the same angle with the horizontal. So let us say I naught is the maximum value of current and E naught is the maximum value of EMF. Both are in same phase. So the value of I we can get like this. So I will be equal to I naught sine omega t by taking a projection on the y-axis. So as this phasor rotates, suppose in the anti-clockwise direction, the value of E and I keep on changing, and these are shown along the same direction because there is no phase difference between E and I. So I naught and E naught are making the same inclination omega t with the x-axis. And both have equal value of angular velocity, that is omega. Because now just because they are keeping in same phase, the angular velocity must be equal, that is equal to omega. Now as this rotates, we can draw how the values of E and I change. We can draw the curves here. So I extend it here and we see how the values of E and I change with omega t. Now first case, when E and I are making angle 0, lie here, the value of E and I will be 0. So we get this point. So this is E and I on this along this axis. So we get this first point here. So when this is making omega t, this is the value. So bring it here. So this is the value of I and this is the value of E. So this is the value of E at any instant of time t, and this is the time corresponding to omega t, because that is as it is moving, omega t is increasing in this direction. So this point will get, one point will get corresponding to I here, another point will get corresponding to E at this position. Okay, so curves कैसी होंगी, if we further go, it rotates in the anti-clockwise direction and reaches is along OY, then we'll get the maximum values, and the maximum value in this case may be this. So if we take this maximum value here, so this will be the maximum value for E, that is E naught, and this will be I naught. You can project these maximum values and get a point corresponding to omega t here, like this. So we'll get these 2 points. So now you can draw the curves. So this E is this much distance. So you get a curve something like this for I and curve for E, like this. So this is for I. This is for E. So as this vector rotates anti-clockwise direction, we get a curve for I as well as E like this. So the values of I and E at any time, at time 0 is 0, at when these two, one it is maximum, at the same time it is 0 again and the same time, and so on. So this is how we get curves for I and E versus omega t, and you will find that these two are in same phase. So from the phasor diagram we can draw the sinusoidal, how the E and I are changing sinusoidally with time t. AC circuit containing inductance only. So we can once again draw the diagram. So inductance is basically what? It is a coil, and we assume that this is a pure inductor. That means there is no resistance due to coil, and that is why it is only a pure inductor, and resistance is 0. So it is an ideal inductor. Okay. Now E is the applied EMF, and E we can write down is equal to E naught sine omega t. That is, it is changing sinusoidally, and E is the instantaneous value at any time t. Now if di by dt, that is the rate of change of current through L at any instant. If this is the rate of change of current, is rate of change of current at any instant. Okay, then through this inductor of inductance L, then the EMF induced, say through L, this is the inductance is L, then EMF that will be induced. We know that EMF is induced whenever there is a rate current changes with time in through inductor. E is given by minus L di by dt. So EMF induced is equal to minus L di by dt. So negative sign means it is opposing the change in current. Okay. Now for the current to flow through this circuit, the opposite EMF must be equal to the applied EMF. Okay. Only then at any instant there will be current I in the circuit. Then therefore E must be equal to minus opposite to it. It should oppose this. Only then the circuit can maintain a current. So it should be minus E, which is equal to minus L di by dt. Okay. So it is equal to L di by dt. And what is this equal to? This is equal to E naught sine omega t is equal to L di by dt. Okay, so from this we can get di. So di will be equal to E naught divided by L sine omega t dt. So from this expression, these two relation, we get di is equal to E naught upon L sine omega t dt. Now let us find the value of I. So this is the change in I. Let us find out I by integrating. Okay. So let us integrate E naught upon L sine omega t dt. So will be equal to E naught upon L is constant outside sine omega t dt. Now what is sine omega t? It is minus cos omega t divided by omega. So E naught upon L and minus cos So I'll write down here will be equal to E naught upon L minus cos omega t divided by omega t. Now this is indefinite integration, so we'll add a constant which is C. Okay. Now let us understand this constant has, because this is being added to this is current, and this must also be current. So this also has the same dimensions as current, the constant, but this constant is not showing any relation with time. It is not changing with time, but it is current. Now because the source of EMF is changing with time, the current will also be changing with time in the circuit, because the source itself is changing with time. The EMF itself is changing with time. So there cannot be any quantity which is current but not changing with time in this circuit. So we'll just discard this. So we'll not consider this constant, and finally what we get is E naught minus E naught, because this minus outside, upon L cos omega t and omega here. So this will be the value of current. Okay. Now let us change this cos to sine, because we have to compare the current with the EMF, which depends, which we have a relation, a sinusoidal, uh, which is changing sinusoidally as sine omega t. Now for comparison, we need to bring it in the same form as E. So changing this, so what we get is I is equal to minus E naught upon omega L, and cos omega t can be written as sine pi by 2 or 90 minus omega t. So we can change cos, because sine pi by 2 minus omega t is also cos omega t. Okay, because this is in first quadrant and sine is positive in first quadrant, so we'll get positive. Now let us bring this minus here and change the sign. So minus को हम यहाँ लेके आते हैं, E naught upon L omega L, that is sine, इसको, this will become omega t minus pi by 2. So what we get is I is equal to E naught upon omega L sine omega t minus pi by 2. Now this term and this term can be now compared. So what is the comparison? The comparison is these are not in same phase. That is, the current is lagging by pi by 2. The current in the circuit is lagging by a phase which is equal to pi by 2. Now to get the maximum value of current, let us find the maximum value on the right hand side. So it will be maximum when this quantity is maximum, and its maximum value is 1. So therefore I naught will be equal to this value, E naught divided by omega L. So I can write down I is equal to I naught sine omega t minus pi by 2. So this is how the current is changing in the circuit, and this is how the EMF is applied to the circuit containing an inductor. So you see that there is a phase difference between the current, AC current, alternating current and alternating EMF. And now in this case, the alternating current is lagging the alternating EMF, or the EMF is leading the current, or the voltage in this case is leading the current. So there will be a phase difference between the two. That means when E is 0, I will be not equal to 0. And when E is maximum, I will be not equal to maximum. So it will change. Now to get the phasor diagram, so let us redraw the phasor diagram, because now E naught and I naught, these phasors will not not in same phase. So there is a phase difference. So there will be a small change in the phasor diagram. So here it is. So if this is the alternating EMF and vector represents E naught and this is omega t, now I current is lagging the voltage. So that means this vector, which is 90 degree to the uh, vector representing the EMF, but in turned clockwise, because this means clockwise means this lags this. So I current lags the voltage, current lags the EMF. So this angle is 90 degree and it is clockwise. And suppose the vectors are rotating in the anti-clockwise direction and they are keeping a phase difference of 90 degree. Then the projection along the vertical axis will give us the values of instantaneous values of the current and the EMF, and we can get the relation. So here in this case, this phasor represents maximum value of current. So this is the value of I and this is the value of E. And when, suppose when this omega t is 0, this is turned like this. So in that case, E will be along this direction and I will be along this direction. So this is how they will look like. So E along this direction, I along in this direction when omega t is 0. And the value of E, sorry, E naught in this direction, I naught in this direction. The value of E will be 0, but value of I will be maximum. So we can get a point 0 for E and maximum value for the current I. तो ये हमारे पास दो पॉइंट्स आ जाएंगे at time 0. So when they rotate anti-clockwise direction, so this value of E keeps on changing, decreasing. Suppose this is the time corresponding to this. So at this time, the I has changed to this value. So this is the point for I, and E has changed to this value. This is the point for E. And you can go on like this, and when this becomes, this turns here and omega t becomes 90 degree, this will, the I naught vector will be aligned along this OX direction. So that in that time I will be equal to 0, E naught will be equal to E naught. So this is the value of E at time when omega t is 90 degree, and the value of this I when it is omega t is 90 degree is 0. So this will be the value of I here. So let us now draw. So it will look like this. And here in this case, like this. So this is how E will change, and this is how I will change. And so on. So this is I, curve for I, this curve for E. So you find that when I is 0, E is maximum. When E is 0, I is maximum, and so on. So they are keeping a phase relation of phase difference of 90 degree, and the EMF is leading, but the current is lagging, because when the value of current is 0, the value of EMF is maximum, that is EMF is ahead of current I. So this is how E and I are changing sinusoidally, but at a phase difference of 90 degree, where E is leading and I is lagging. Now let us discuss this value of omega L. Again, compare this with Ohm's law. Ohm's law, current is equal to potential difference or voltage divided by resistance. So resistance limits the current. Now comparing this with this, so I naught is equal to E naught divided by omega L. So current is equal to potential difference divided by this quantity which is serving as resistance, which is limiting the current. So this is what is serving as like a resistance in a DC circuit. So this quantity is called the inductive reactance. So omega L is called inductive reactance, and it is represented by, because this is due to inductance, XL, and it is equal to omega L. So inductive reactance limits the current in an inductive circuit, like resistance limits the current in a resistive circuit in case of DC. Okay. Now omega we know is equal to 2 pi nu and L. So nu is the frequency of the AC supply, the alternating current that is being supplied. Okay. Now when nu is equal to 0, XL will also be equal to 0. That means when DC is supplied to an inductive circuit, in that case the value of inductance is 0. That means it does not oppose the current. So there is no opposition to the current by the inductor when the frequency or the DC supply is given to the circuit. Now to get the dimensions and its units of XL, we know XL again is equal to omega L. Omega is equal to 1 upon second and L is Henry. These are the units. And what is Henry? So 1 upon second as it is. And Henry is volt second per ampere. Okay. So we can write down 1 upon second and volt divided by ampere per second. So what we get is, rather यहीं से हो जाएगा, ये सेकंड से सेकंड कट गया और हमें क्या मिला, वोल्ट पर एम्पियर, so which is ohm. So the unit of the inductive reactance is same as the unit of resistance. So dimensions of inductive reactance is same as dimension of resistance.